All right, let's talk about C. If you're learning the language, I'm willing to bet there's one word that makes your stomach drop just a little bit. Pointers. Yeah, they've got this reputation for being super difficult, right? Well, I'm here to tell you that reputation is kind of bogus. Over the next few minutes, we're going to pull back the curtain, demystify this whole thing, and show you why pointers are actually one of the coolest, most powerful tools you have in C. So, what's the deal? Why is this the most feared topic in C? Honestly, it almost always boils down to just one little misunderstanding of the core idea. Our mission today is simple. We're going to clear that up completely. We're going to swap out that fear for some real confidence. And here's exactly how we're going to do it. Okay, here's the game plan. First, we'll tackle why pointers are so powerful in the first place. Then we'll get into the core concept, what they really are. After that, we'll see pointer arithmetic in action, check out some advanced techniques, and then, and this is super important, we'll cover how to avoid the common traps. By the end, you'll be on your path to mastery. Let's get started. All right, section 1, why are pointers so powerful? I mean, really, why even bother with them? Well, it's simple. Pointers are the key to high performance and control in C. They are the secret sauce, the reason C is famous for being so incredibly fast and letting you get right down to the middle. If you get this part, the rest will click into place so much easier. So here's the deal. Pointers give you direct access to the computer's memory. Think about it. In a lot of other languages, you're kind of asking the system, hey, can you please go get this data for me? It's indirect. But with C pointers, you're not asking. You're going straight to the source. You're saying, I know the exact address where that data lives, and I'm going there myself. That raw direct access is what enables all those crazy performance optimizations. But it also means you're holding the map. It's on you not to get lost. Okay, so if it's all about direct access, how do we actually do it? This brings us to the core concept. And I want you to do me a favor. Forget all the complicated, scary stuff you might have heard. Just for a second. Because at its very heart, it's all about one simple thing, the address. Here it is, the single most important definition. A pointer is just a variable whose value is the memory address of another variable. And the analogy that makes this click for everyone is this. A regular variable, like an integer, is the house. It's the physical place where your data lives. A pointer? It's not the house. It's just the address to the house written on a slip of paper. That's it. It doesn't hold the data, it just holds the location of the data. And to work with these addresses, you only need to know two operators. Seriously. Just two. First, you've got the ampersand, and. Think of this as the address of operator. You put it in front of a variable, and it gives you the address of that house. So now you have the address on your slip of paper. Great. What's next? Well, you use the asterisk, star. This is the dereference operator. It means go to the address on this paper and get me the value that's inside. Get the address, then get the value. That's the core loop. If you get this slide, you are well on your way. Okay, so we know what a pointer is. It's an address. Now, what if you have a whole neighborhood of houses, like an array? How do you move from one to the next? That's where pointer arithmetic comes in. This isn't your normal addition and subtraction, though. It's a special kind of math built for moving through memory with purpose. And here is the absolute key to understanding it. When you do something like pointer plus 1, you're not just adding the number 1 to the raw memory address. No. You're saying, move to the next element. It's a much smarter operation. Here's what I mean. Let's say you have a pointer to an integer. On most systems, an int takes up 4 bytes. So when you do ptr++, the compiler is smart enough to actually add 4 to the address to get you to the start of the next integer. But if you do the same thing on a char pointer, which is only 1 byte, it just adds 1. See? The compiler handles the size of the thing you're pointing to automatically. And this is precisely why pointers and arrays are like best friends in C. It's how you can efficiently just walk right through an array. All right, you've got the fundamentals down. You know what a pointer is, you know the operators, you know how to move them around. So now, let's unlock some new levels of flexibility with a few advanced pointer techniques. And don't worry, they might sound intimidating, but they're just logical next steps from what we've already covered. First up, the infamous pointer to a pointer. You'll see this written with 2 asterisks, and it can look pretty scary, but it's not. It's exactly what it sounds like. A pointer to a pointer is just a pointer that stores the memory address of another pointer. It's just adding one more layer. Let's go back to our analogy. Step 1, you have a box with some value in it. That's your variable. Step 2, you have a piece of paper with the address of that box. That's your pointer. So, what's a pointer to pointer? It's just a second piece of paper that has the address of the first piece of paper written on it. That's all. It's just a way to find your address sheet. Okay, so we know variables have addresses, but guess what? Your functions do too. When your code gets compiled, the instructions for each function are stored somewhere in memory. And that somewhere has a starting address. And hey, if it has an address, we can create a pointer to it. And that's exactly what a function pointer is, a variable that stores the memory address where a function's code begins. Now, why on earth would you want to do that? Because it allows you to treat functions like variables. You can pass them around, you can store them, you can decide at runtime which function to call. This is the magic behind things like callbacks. A great example is C's standard sorting function, qsort. You give it your data, but you also give it a function pointer that tells it how to compare two items. This makes your code unbelievably flexible and dynamic. Okay, we've talked about all the cool, powerful things you can do. But you know the saying, with great power comes great responsibility. This next section is arguably the most important one. This is the essential safety manual. Because look, anyone can learn the syntax of pointers, but knowing how to avoid the common traps, that's what makes you a safe, effective, and professional C programmer. Your number one safety tool is the const keyword. But with pointers, where you put const changes everything. Let's break this down. In that first example, const int p, the const applies to the int. This means the value it points to is constant. Using our analogy, you can't change what's inside the house, but you can make your pointer point to a different house. The second one, int star const p, is the opposite. Here, the const applies to the pointer itself. The address on your piece of paper is written in permanent ink. You can't change where it points, but you are totally free to change the stuff inside the house it points to. Understanding this difference is crucial for writing safe code. Next up is maybe the most notorious, hair-pulling-out bug in all of C programming, the dangling pointer. So what is it? A dangling pointer is a pointer that used to point to valid memory, but that memory has since been freed or deallocated. The memory is gone, but your pointer is still holding on to that old dead address. It's just dangling there, pointing to nothing you own anymore. And if you try to use it, you get crashes, corrupted data, or just the weirdest bugs you've ever seen. And here's the classic textbook trap for how this happens. Step 1, a function creates a local variable. That variable lives on something called the stack. Step 2, the function returns a pointer to that local variable. Step 3, the function exits. And when it exits, its entire stack, including that local variable, is wiped clean. It's gone. So what about the pointer you just got back? Step 4, it's now dangling. It's pointing to a memory location that is total garbage. This is a huge, huge no-no. Okay, last trap, and this one is super important. We need to be crystal clear on the difference between a null pointer and an uninitialized pointer. A null pointer is your friend. It's a pointer that you have intentionally set to point to nothing, to address 0. It's a known safe state. You can check for it with a simple if statement. But an uninitialized pointer, that's a ticking time bomb. It hasn't been given a value yet, so it just holds a random garbage memory address. If you try to use it, who knows what will happen? It will almost certainly crash your program. The lesson? Always, always initialize your pointers, even if you just set them to null right away. Whew, okay, we have covered a ton of ground, right? We went from the absolute core concept of what a pointer is, all the way to advanced techniques and the critical safety rules. So let's bring it all home. This is your path to mastery, what you should take away from all this. Let's boil it all down. First, pointers are just addresses. That's it. Second, the ampersand, and, gets an address. The asterisk, star, gets the value at an address. Third, pointer arithmetic isn't simple math. It moves by the size of the element. Fourth, advanced stuff like pointers to pointers and function pointers, they just add more flexibility. And finally, and most importantly, always be mindful of safety. Use const, never create a dangling pointer, and always know the difference between null and an uninitialized pointer. So I want you to walk away with this in your head. Pointers are not magic. They aren't some black box you're supposed to be afraid of. They are just addresses. That's all. It's a simple, direct tool, and now that you know the rules, you are the one in control. You've learned the rules, you get the concept. The fear should be gone because now you have knowledge. You understand the power you've been given. So the only real question left is, what are you going to build with this power? Thanks for tuning in.